Hello. Huh. I, Shivam Prajapati,
And I, Rishita Thakur, we would like to welcome you all on behalf of FEV India. Hope you all are well settled now.
dear guests, speakers, and fellow technocrats. It's an absolute pleasure to have you all here today as we gather to celebrate and explore the latest trends, innovations, challenges, and solutions in the field of NVH technology. As we all know, NVH plays a critical role in ensuring the comfort, safety, and performance of automotives. The ability to analyze and control noise, vibrations, and harshness plays an important role to achieve optimal product design and user experience.
Today, we are not just talking about NVH technology, but we are exploring role of NVH in future mobility. We are passionate about making the world a quieter, smoother, and more comfortable place. We are pushing the boundaries of what's possible. We are challenging ourselves to think out of the box. As we embark on this exciting journey, we want to remind you that we are a part of something bigger like revolution. We are part of global movement that is transforming the way we think about NVH in vehicles. We are thrilled to bring together FEV's experts in the field of NVH that will cover a wide range of topics. To begin with, I would request our MD, Mr. Vijay Sharma, to welcome our guests for the day and brief us on FEV insights.
Everyone. Yeah, that's it. Yeah, for this. So I was asking my colleagues that why did we plan to have this conference on the second floor? So I believe this was not a fitness test, but if you make it up and down 2 times or 3 times during the day, this is a good exercise for us. Yeah. So ladies and gentlemen, good morning to all of you. I'm very happy to welcome you all on this NVH conference. We have a very interesting and exciting day in front of us. One side we have Mr. Akela Sharma, chief guest of the day, to honor this event with more than 25 years of experience into the vehicle safety, NVH, responsible for NVH activities at Mahindra, and responsible for the entire life cycle development. So very warm welcome, sir, to this event. We have distinguished guests all across Indian automotive industry to participate in the discussions today. So very warm welcome to all of you as well. We have an excellent expert panel for the technical presentations today. We have Dr. Christoph Steffen and Mr. Jan Oppe from Europe. We have Dr. Kiran Govindswamy from FEV North America and Mr. Sachin Wag from FEV India. So I'm pretty sure we are going to have a very exciting day today during our presentations and discussions. Our colleagues also planned some interesting things for you. I think they have planned some quiz sessions, and the colleagues who are most attentive and they can answer their questions, they have some surprise gift for them as well. So be prepared for this exciting part as well. At the end of the presentations, we have planned a short facility trip to our Powertrain and Quick Chamber. This is one of the best facility all over India, and I'm pretty sure that after this event, you have a chance to look this facility and also to utilize into your programs later on for this. Yeah. So again, very warm welcome to all of you this event, and let's make best use of it, and let's learn together from this event. Besides the welcome, I also have a few slides to give you a brief introduction of FEV. I'm pretty sure FEV is not a new name for you, and also to make initial remarks about this event. So, I think by the time his colleagues correct this, FEV is a global engineering solution provider. We are close to 7,300 experts. We are located at more than 40 locations all over the globe. And wherever our clients are setting up their locations all across the globe, FEV is also moving closer to the client and so on. So we have multiple locations. We have multiple locations into America. We have multiple locations into Europe, and also multiple locations into Asia. Just a moment. Can we see this? Okay. So I already covered some part of this. We are at more than 40 locations globally, 7,300 experts working all across the locations, and you could see that Professor Dr. Stefan Pischinger, who is the president and CEO of FEV Group, so who is guiding us, motivating us, and helping us to support our activities at all the locations. You could see that we have multiple centers into different regions. Of course, many subsidiaries in Europe, multiple locations in India, and a few locations in America as well. Coming to India, we started in 2006. We started small. We set up our technical center in 2009. As on today, we have 6 locations in India. Out of these, 3 locations are in Pune. One location is technical center, where we are sitting today. We are doing all our testing, validation, calibration, benchmarking activities from this center. We have our vehicle design center at Auto Cluster in Pimpri Chinchwad. We have our electrification and software activities at Smart Mobility Center in Baner. So we have these 3 locations in Pune. We have 2 software centers, one in Chennai, that is in IIT Madras Research Park, and the second is in Jaipur. Since beginning, we have our project and business development office from Delhi. And currently, we are ramping up our team in Bangalore, and soon we'll set up our seventh office in India. So you could see that not only globally, but India as well, we always want to go closer to our client and work together with them. India Center is very important for FEV Group. One side, India is a big market for us. We find many interesting clients and interesting projects. But other side, India Center is also used as a talent pool, and we have multiple global competence centers to support even the global projects. And the topic which we are discussing today, especially the NVH and the CAE, this is also one of the competence center we have in India. This slide just shows an example that how FEV is supporting automotive mega trends, and how FEV technical solutions are complementing these trends. If you see the first example, we have built a battery electric vehicle demonstrator called SWAN, where we have demonstrated the new mobility concept, especially the car sharing. The second example is we have set up world's biggest battery development and testing center in Europe. So this shows FEV commitment towards future mobility requirement, and FEV has done probably the maximum number of battery design and development project for different clients across globe. Another example, we have our own vehicle where we have demonstrated autonomous drive, level 3 capable vehicle, and we are supporting our client for such kind of topic. We have also built a software-defined vehicle platform to demonstrate the next generation EE architecture, and we are supporting many clients even for this new generation EE architecture topic as well. Propulsion technology, multiple options, especially the hydro IC engine program. Even from India, we are doing a production program for the hydrogen IC engine development. E-fuel, I think a lot of discussions are going on that this could be an alternate to the fossil fuel. Hydrogen fuel cell propulsion, this is also one of the topic where FEV is doing a lot. And just to give an example, we have demonstrated FEV engine with more than 45% efficiency with hybrid electric combination and so on. Now coming to India, if you look the major trend, I think everybody is talking about the electrification at the moment, and I think if we would have talked 5 years before, nobody could believe, but today we are realizing that how important is electrification for the Indian market, and if you just have a look to FEV scenarios, we have prepared the moderate scenario and accelerated scenario already by 2030. We expect the market size of around 5.7 million vehicle sales every year. And as per the moderate scenario, around 25% of the new vehicle sales will come out of the electric vehicle. And from the accelerated scenario, it's around 30% of the new vehicle sales coming out of the electric vehicle. And this trend is for the passenger vehicle, four-wheeler, up to 3.5 ton, which includes the passenger as well as the light commercial vehicle. If we talk about the two-wheeler and three-wheeler, I believe this transition is much faster, and we are already expecting around 80% electrification by year 2030. If you have seen the news from last 1 or 2 months, Mahindra has already announced that already they might get to 30% by 2028 already. Similarly, Audi and other organizations are also making their plan out for this. So electrification is very, very important for the Indian market. Now coming to the today's topic, NVH. NVH is becoming very, very important for the vehicle as a whole. And if you look this attribute leadership scale, now NVH is getting more and more important and getting into the leadership role. This is just an example, one project which we have done where we had to define the target definition for the vehicle, and we have to compare with the two benchmark programs. And you could see that beside the design appearance, safety, perceived quality, NVH is also among the leadership attribute for this. And if the one important thing is that the NVH is the only leadership attribute where all two benchmarks are also into that the leadership attribute. So just to give an example that how NVH is getting the important, that when you are defining the target, when you are defining the attribute leadership, you are giving the highest position to the NVH attribute for this. Regarding NVH sources for the battery electric vehicle, I'm pretty sure we are going to discuss more in detail when we have the presentations from the colleagues, but at the top level, from the EDU, a lot of noise sources, mechatronic components also causing the sources, especially for the road noise and wind noise. It's very special for the road. I think it's a dominant at the lower speed, and for the wind, it's a dominant at the higher speed. And we don't have any IC engine masking anymore. So that's why we have to find the new ways to cover those noise aspects. Regarding my expectations from the conference, that we should not see NVH as a problem only or only as an emission, but we should also see this as an opportunity. An example, like we can talk about acoustic vehicle alert system for the pedestrians, so we can even use this for the safety purpose. And we can also use sound as a signature, especially for any particular product or for any particular OEM as a brand for this. Yeah. Beside this, I think lightweighting is also one of the important topic for the NVH, and not only the NVH, especially for the electric vehicle, because everybody want to get the larger range, so you have to go for the lightweight. So that's why a lot of new material investigations and analysis are happening, but there is also, you have to find a right balance between the range and the NVH performance. And also, then you have to find a new way to cover buzz, squeak, and rattle noise sources out of the vehicle for this. From the EDU side or the motor side, I think electromagnetic is also one of the topic which we believe that now the new simulation techniques have been established, so we can tune the product already at the virtual development stage itself instead of tackling this when the physical product is available for this. Yeah. That's all today I wanted to share with all of you. Again, very warm welcome to all of you to this event, and I'm also equally curious, equally excited, equally interested to see all the presentations and participate into the discussions. Thank you very much for this.
Thank you, Mr. Vijay Sharma, for your inspiring words. To commence the day proceedings, we would like to begin with our traditional Indian ritual of lighting the lamp. This ceremony symbolizes the victory of light over darkness, knowledge over ignorance, and good over evil. I would like to request our esteemed guest of honors to kindly come forward and join us on the stage for the lamp lighting ceremony. Please join me in welcoming Dr. Akela Sitarameshwara Sharma, Chief Engineering Head, Engineering Analysis and Vehicle Development, Safety and NVH at Mahindra & Mahindra Auto Sector. Dr. Ulrich Fahl, Chairman at FAV Asia. Dr. Christoph Stephens, Department Manager and Global Chief Engineer, NVH at FAV Group. Dr. Kiran Govindswamy, Senior Vice President, Drivetrain, E-Mobility and Vehicle Engineering at FAV North America. Mr. Yan Ope, Department Manager, CAE at FAV Group. Mr. Vijay Sharma, Managing Director of FAV India. Mr. Sachin Wagh, Director of Vehicle and Consulting at FAV India. Thank you, everyone. May I now request you all to take your seats. I hope that the light from this spiritual lamp will ignite our intellect to create better technology. Now I would like to invite our chief guest, Dr. Akhila Sitarameshwara Sharma, Chief Engineer, Head Engineering Analysis and Vehicle Development, Safety at NVH at Mahindra & Mahindra Auto Sector, to share his word and experience on the transition towards which automotive industry is heading.
I have to really do the pressing. The I have to do that, right? Or you do it? It's okay, not now. Oh, it's thank you. Good morning. Yeah. So, with the great introduction from Vijay Sharma from the FEV, and first of all, it's a great pleasure to be part of this particular tech day of FEV, and the kind of the focus what Vijay Sharma has shared. I think most of the engineers will definitely see that EV development requires a lot of attention to the NVH kind of stuff, but at the same time, as a vehicle engineering kind of thing, I just want to touch upon, what is important. Of course, NVH is very important, but as a vehicle engineering, you need to really do a lot of balancing act, with respect to a lot of those attributes you really, work on for an EV kind of development. So, I'm just putting a kind of, vehicle attribute balancing, but what is the focus for NVH from this? That's what I just wanted to give a very, very, quick and maybe not more than 5 slides. So this is what it is for any kind of a vehicle development, whether it is the EV or ICE. But for EV, this is most important thing is the NVH, but I will just come to that. But if you look at it in a holistic kind of a vehicle engineering, the crash, the NVH, and you have the durability, and also you have a dynamics, and also the lot of those other attributes come into play. But majority of the attributes for the vehicle engineering is among these. The most important thing in terms of meeting these kind of attributes, the set targets. The set targets will come from your benchmark vehicles. So once you arrive at a benchmark vehicles targets, then you start working on these kind of attributes, right? But each and every time, NVH is a separate department. You have, the expertise is different compared to your crash. But when you develop these in simulation and as well as the physical vehicle development, there is a kind of a tendency of each person to actually meet that kind of set targets by adding weight. The adding weight is the only way to get out of the kind of performance issues what you face generally. Of course, there are some technologies, the new materials and things like that are there, but the most easiest way of getting, the performance issue out is only to add weight. Whether it is a durability or the NVH or any other kind of a crash. So, how do you really balance these attributes with respect to the target weight? Because the weight is going to be a very critical for EV development, EV kind of vehicles, because it is influencing your range, and the kind of course, the style is also influencing on the range, but the weight is also influencing the range. So, what you are supposed to do for this kind of a thing, for example, if you work on a BMW, so how do you balance this? I think you need to really get into this, the multidisciplinary optimization, where you need to really understand what are those mutually dependent load cases or mutually dependent systems for these domains, and then segregate them, and with a kind of an addition of weight, you can meet the kind of, the DVPs of each of these. That is the mutually dependent systems, right? Then you can actually see the mutually independent systems that you need to really get into that. So that's, you have to really handle those kind of mutually independent things. But the dependent things, you need to really get into a multidisciplinary optimization, where you need to really come out with a lot of those proposals for, the meeting the performance, and as well as the reducing the weight if you take up this as an individual load case in your NVH or a durability. So that's the reason this is becoming a kind of need of the hour, that everybody has to get into a multidisciplinary optimization. It's not one optimization, whether it is a durability optimization or a NVH optimization. So this is one thing which I wanted to tell you. This has to be done very rigorously on your EV development, even in the simulation stage. If you look at the NVH as a kind of a focus area in this, so what is that? I think this has already been explained by Vijay Sharma, but I just wanted to touch upon, what are those new elements or new sources for NVH? It's very clear from the powertrain is the kind of a whine noise that is going to be there, whine and regeneration noise. This is what we need to deal with, in the EV development. And the compressor noise. These things are actually not been addressed or even focused at all in a ICE development. But there is a lot of, EV ke liye, for EV development, we need to really focus on this AC compressor, noise vibration, and battery charging noise. You have a road boom and humming. It is very typical when we drove some of the vehicles in Europe, in Belgium, we just drove some 3 or 4 vehicles there, and all of them are having this kind of noise. Even I'm talking about some of the best-in-class vehicles what we really see in European roads. So the suspension and underbody noise, this is becoming a biggest thing, particularly on Indian roads, and what kind of suspension and how you are actually isolating your kind of the inputs coming from the road, and the underbody noises are very, very important to really focus on. And the structural radiation and wind NVH, that's what is going to be. I mean, these are the major kind of the sources that you need to really deal with for EV. So why we are focusing? Because this is how it is, the kind of, when you look at I have taken this from the source is mentioned there. So if you really look at for ICE, the road and wind is actually a 35% is coming from. But whereas in your wind and noise, in the wind and road, for a BEV kind of thing, it's more than 65, almost 65% of the thing which is coming. So you know what exactly is the kind of a thing that you need to focus. And powertrain noise, which is a 15%, I know, which we talk about in the EV, and then it was very high in terms of, you know, the ICE vehicles. Whereas in the auxiliary kind of systems, you actually see how much percentage is coming, and then now, you know, we need to, and BSR, and, you know, whatever morning we have seen the slide BSR, and then, you know, the brake pump, steering rattle, and everything comes around, you know, 20% of the kind of in the EV. So this is very clear for every NVH engineer for the EV development that they need to focus on. I just wanted to touch upon that, you know, why we are touching upon these things is the kind of the importance is coming from the from the source. You know, you can see, you can look into any of the kind of thing. This is how the NVH, the sources are for a EV. Okay, having said that, I just want to give one slide for the FEV. You know, as a kind of a technology partner, I know Mahindra is already working with them, and what we look from them as a kind of, you know, EV development for all our future vehicles is something like the recent technologies and structured processes. We want to really get into this, and we know how to deal with this in terms of ICE kind of, you know, configuration. But on the EV side, we want a little bit of, you know, the technology aspect, and as well as the process aspect. You know, that we are definitely look forward to, you know, in terms of all these electromagnetic noises, and then transmission and motor whine. You know, we need to really eliminate these. Road noise, the prediction and containing measures, you know, the road noise, and then underbody noises, complete elimination of underbody noises, and the wind noise, and reduction of high frequency noise from electronic systems. So if we concentrate on these kind of things, and then we are going to be the best in class, whatever it is, you know, whether it's a Tata or a Mahindra or a Maruti or, you know, Suzuki, whatever it is. So these are the only aspects I think we need to address on, you know, on the EV development side. That's all from my side. I just wanted to touch upon, and there is one more thing which is very important slide which I wanted to tell you. Without that, I'm not going to complete, or I'm not going to really end any presentation. Decided not to end any presentation going forward. So this is the commitment from Mahindra, which is the ESG, that is environment, social, and governance. So this is what we are committing to the planet, and you can just go through that. It's a kind of, you know, circularity of the materials that we are talking about, the climate change, and the kind of, you know, what we are committing, renewable energy, and you can see that women empowerment, the energy productivity part of it, the carbon footprint, how to reduce, you know, what we are committing to the next, you know, couple of years. You know, this is what exactly is the thing which I wanted to tell you, that every organization has to come forward and do something for the ESG. Thank you very much.
Thank you so much, Dr. Akela Sharma, for sharing your valuable words. Now, I would like to invite Dr. Kiran Govindswamy, Senior Vice President at FEV North America, on stage to present on future powertrain trends, NVH challenges and solutions. Dr. Kiran has career span of more than 20 years at FEV. He has held several positions in NVH, component engineering and vehicle integration. He is responsible for leading engineering and development activities at FEV North America in areas of drivetrain, e-mobility, and vehicle engineering business.
Yeah, thank you for the kind introduction, and good morning to all of you. It's a pleasure for me to be here at FEV in Pune, and it's a great day to be here. So Thank you for the opportunity, and I look forward to some interaction after my presentation and hopefully a discussion during the breakout sessions, etc. So my presentation today is titled Future Powertrain Trends, NVH Challenges and Solutions. So I'll touch upon various areas which we think are important in terms of trends globally. I'll give you a little bit of an American perspective because that's where I come from, and yeah, we are all globally connected, and all the companies here are also global companies, so hopefully you find that useful. And we'll try to connect the dots, so to speak, and hopefully the presentation makes sense. So in terms of an agenda for today, I'll go through a very brief FEV overview just to provide some context. And the context is mostly in the area of vehicle development and e-mobility. Following that, I'll get into just a little bit of North American test facility overview to show you what we have there and what we are doing in that area. Then get into global powertrain and drivetrain trends, which is important to see where various parts of the world, how we're looking globally, and how is the US market looking in particular. And you'll see that it's a combination of HEVs and EVs. So we'll get into some HEV or hybrid electric vehicle challenges and solutions, and then sort of graduate from there into BEVs, and then end up with a summary and hopefully have some time for questions after that. So just to provide some context, if I look at FEV's vehicle engineering capabilities, this is the breadth, and we have the same capabilities in Europe and in Asia as well as Americas. So we start with vehicle architecture on the extreme left, where we are doing full vehicle development, and a lot of them end up being BEVs these days. Certainly chassis development and EE integration, body in white development, exterior, interior, defining the lighting and the DNA of the vehicle, and all of the attributes. So Dr. Akhilesh Sharma talked about attribute development, and certainly everything here, vehicle dynamics, durability, thermal management, NVH, etc., falls here. And you really need a holistic view, full systems engineering approach, like you said. And NVH is an important attribute, and this is where it fits in. And last but not least, we support our customers all the way through production, through launch of the vehicles, and taking care of issues that might come up there. So with that, I also wanted to spend just one slide talking about e-mobility and what that means in the context of FEV. So e-mobility is everything you see here. It's development of electric drive units, and they're mostly these days called 3-in-1 systems because you have the motor, you have an inverter, and the gearbox, all integrated into electric drive units. So that's the heart of the EDU powertrain. Of course, there's fuel cell development happening, a little bit, I'd say, at the lower level in light duty. It's probably at a high level in medium and heavy duty, but also fuel cell stack development and all the balance of plant and system development. Full battery development, which, should also be the heart of the BEV. And finally, integration of all these components into the vehicles, including the controls, the EE, and the mechanical integration, etc. So this is all, let's say, the various fields that encompass e-mobility. And NVH is a critical attribute that needs to be managed to bring all this together. So with that, I'll get into global powertrain and drivetrain trends, just to give you a picture on how we see the world globally, to start with. Vijay talked about the Indian market, and so that's part of what you'll see here. Oops, the next slide should be global powertrain trends, which I'm not seeing here. Is it hidden, perhaps, the slide? Let's try if we can. Yeah. Okay, that's okay. For some reason, the slides appear to be hidden, so I'll come to that later, and maybe I'll verbalize that. So a little bit about the FEV North American facilities, just to put things in perspective here. So we have multiple test cells in multiple, let's say, buildings. On the extreme left, you see all the IC engine and hybrid-based development. So all dyno cells that support various fuels, including integration of electric machines and hybrid drivetrains, including NVH. This area here is what we call our vehicle and drivetrain center. So that includes everything that does not need an IC engine, so electric drive units, motors, etc. This is our vehicle development center. The centerpiece of this is a all-wheel drive climatic chassis dyno, which is used for thermal management optimization in addition to NVH and full range development for BEVs. And lastly, benchmarking, which is a big part of our activity where we do teardowns of vehicles and look at components and try to connect the design features of electric motors, batteries, inverters, etc., to the test data that we measure and try to connect the dots. So NVH in particular, there's two cells. I won't get into all the details, but fundamentally they're flexible. They end up supporting a variety of powertrain configurations, ICE, hybrids, electric machines and drive units. And a similar second cell that also incorporates full vehicles as well as small components, as you see here, which is a belt starter generator. So everything from a small machine to a full vehicle, depending on our customer's needs. So with that, yeah, the global powertrain, drivetrain trends actually comes next. So I was mistaken in the order. So this is the global view in terms of where we see the industry heading. So you can look at 2019 and the dip that happened in 2020 because of COVID. But the good news is past that, we do still see an increase through the next decades or decade and a half. So with a compounded annual growth of 1.2% globally. So that's the good news for the global, let's say, increase in vehicle development. A big chunk is battery electric vehicles globally. Of course, it depends on region, and it's very dependent on which region you're talking about. But in addition to this, you have vehicles with IC engines sort of going down. It doesn't go down to zero. It's still there. And a lot of them end up being hybrid vehicles. So we see strong growth in electrification in BEVs, a small growth in fuel cells, which you see with the blue sliver on the top, but also various vehicles with IC engines, including hybrids. So with that, what does a hybrid mean? I just wanted to put things in perspective here. So on the extreme left of this graph is IC engines only. So this is non-hybrid, just IC engine conventional vehicles. On the extreme right, what you see here is battery electric vehicles and fuel cell electric vehicles. So EVs, be it BEVs or fuel cell EVs, on the extreme right. So between the extreme left and the extreme right, you see there's a long bridge. And this bridge is the different degrees of hybridization. You start off with mild hybrids that have stop-start to start with. Micro hybrids with stop-start. And then you get into mild hybrids, which include stop-start. You include some ICE load shift to get your engine to operate in the best fuel efficiency area, and some boosting capability. Then you get into full hybrids, plug-in hybrids, and all the way into BEVs. So there's a long bridge to go from conventional IC engine vehicles all the way into BEVs. So this is characterized by increase of power of the electric machine, and there's many hybrid configurations present, which we won't get into all the details yet, but I'll show you a couple examples. So this is looking at different scenarios, specifically in the US market. So if you look at historical data, in 2022, we were at 5% BEV, so relatively small, but we still see a growth there. In the moderate scenario here, we expect to be in the 21% range for BEVs in 2030, and in the accelerated scenario, we expect to be at 37%. So somehow not too different than the Indian market from what I saw earlier today. So very similar. Of course, there's a whole bunch of hybrids. So the different bars here, we start off with IC engine only. There's this one in this example, including stop-start. Then you get into mild hybrids and plug-in hybrids and BEVs. So that's the spread we see. So strong growth in electrification, no matter which scenario you look at, but perhaps not as significant growth as we might see in Europe or China, but rather similar to India. So that's at least how I see it. And certainly a lot of hybridization that will come into play along the way. So if you look at, these two scenarios which we just talked about, in whether it's moderate or accelerated, there's a whole bunch of BEVs and a whole bunch of hybrids. So when it comes to transmission development, right, what does that mean? So we think, and at least this is a US perspective, it's of course dependent on the market, but all the rear-wheel drive hybrids will be clustered into what we call P2 hybrids. So the electric machine is sandwiched between the engine and the transmission, and with some electric drive potential, but it's fundamentally a modular architecture where you leverage an existing transmission and you adapt an electric machine to it. The front-wheel drive architectures, in the meantime, will be what we call dedicated hybrid transmissions. So you have one or two electric machines integrated into the drive unit, and they're called DHTs because they are custom-built hybrid transmissions. And of course, for EDU, there's a lot of development for electric drive unit development. They support BEVs, fuel cell electric vehicles, P4 hybrids. So in the P4 architecture, the front axle of a vehicle might be driven conventionally, but the rear axle is electric. That's a P4 hybrid. And range extenders, which is a series hybrid configuration where the engine drives a generator, and then you have an electric drive unit that is electrically propelling the vehicle. So there's a lot of EDU activity in all these areas, but fundamentally the architectures here is what we think will happen in terms of hybrid transmissions. So with that, I'd like to look at just at a high level, what are the HEV and V8 challenges and what are potential solutions, and then we'll get into BEVs next. So this is just an example of a typical power split hybrid transmission. So there's many companies working on these concepts, so I'll take you through what this means. So this is the engine. The engine is then connected to the carrier, as you see here. The electric machine is connected to the sun gear of this planetary gear set. The ring gears are connected to each other. You have another electric machine called MG2 connected to the sun gear, and the planet carrier is grounded, and this is the output that drives the vehicle. So if you look at this, there's two electric machines called MG1 and MG2, and this is called a power split transmission because the power is split between the engine and the electric machines in how the vehicle is being propelled, and you end up with a continuously varying ratio between the engine and the output. So that's why it's called an electrically variable transmission, EVT, or it's a power split hybrid. So there's multiple sources here. So if you look at that, there's lots of NVH issues that come into play when this vehicle is operated. So in this plot here, you look at the requested torque from the driver on the y-axis and vehicle speed on the x-axis. So in EV only mode, you're right here. EV or regen, you're dealing with electromagnetic noise, gear train noise, whine, etc. When you cross over from EV mode to when the engine kicks in, of course you go through engine start-stop, and I'll show you some examples in terms of what this means and what the solution potential could be. And then, of course, when you get into driving the engine at higher torque and into its sweet spot for efficiency, you get into torque fluctuations that lead to driveline boom, etc. Yeah, so these are all the issues one might expect with a power split hybrid. So just let's talk about start-stop for a second. So any of these problems, the first fundamental issue is to understand the mechanism as to what might be going on. This particular example, we're looking at seat track acceleration on the left. You see there's two phases. There's the engine cranking phase right here, and there's a start of combustion phase right here. So if you stare at the graph long enough, you'll see that the major problem is happening during the cranking phase, and you have a minor issue in the start of combustion phase, right? This might not always be the case, but that is the case here. So in this particular case, it turns out that you can actually use active vibration control. You can use these two machines, MG1 and MG2, and you can modulate the torque of these machines as shown here in green for MG2 and MG1, and in doing so, you get from green to black. So if you modulate the torque, you're able to actively control the vibrations in both the phases, in the cranking phase and the combustion phase, and you can mitigate this and make this a very refined stop-start experience for the customer. This is one example. Another example here is also looking at a similar situation, but you'll notice here that in the cranking phase, the vibrations are not significant, but in the start of combustion phase, it really picks up. So it depends. So it's very important to understand the mechanism as to what might be causing it. It's important to understand what the driveline modes are and how can you tune them, right? How can you tune mounting of the powertrain, and then also define what kind of a system you might use to start the vehicle in terms of providing the stop-start functionality. So these are key factors that can be used in addition to active vibration control to control the refinement of the start-stop in the vehicle. Moving on, this is start-stop noise, similar to vibration, but of course it's a noise issue in this case. As you can see, you start off in EV mode, your noise levels are relatively low initially, then it suddenly picks up, and you want this transition to be smooth and not be abrupt. So what can you do there to minimize concerns from an NVH perspective? There's many things you can do, but one thing to keep in mind is, and this is an example where we actually had the engine start and stop and start and stop, And you can see if you maintain a 15 dB type, let's say, gap between the noise level in the vehicle and the noise level from the engine when it comes up and down, then that becomes relatively imperceptible and not noticeable. So that's a guideline to work towards. So there's things you can do from an engine calibration perspective. Of course, you have to minimize the engine noise, which is conventional techniques, be it radiated noise, vibration of the mounts, or intake and exhaust. And lastly, looking at the sensitivity of the vehicle from an airborne, structure-borne perspective. So if you go after this clinically, it is possible to make this also be a solvable problem. The next area, if you remember, we talked about the higher torque demand in certain parts of the vehicle drive cycle, where the engine is asked to do more. And in that case, in hybrid vehicles in particular, you might look at more, let's say, more efficient combustion engines. So in this case, we show scatter bands from FEV for crankshaft torsional fluctuations as a function of speed for gasoline, PFI engines, for GDI engines, and diesel engines. So as you increase combustion efficiency, you'll notice the crankshaft torsionals go up. And interestingly, the same thing happens when you go towards decreasing cylinder count. So V8 to V6 to I4 to I3, the same idea. So as a combination of the two, you have a lot of torsional fluctuations feeding into the driveline, which need to be managed. So to take care of a problem like this, of course, you have to work with multi-body simulation models. We've shown virtual dynamics example from FEV here. And look at damping systems, a torsional damper in the transmission, a twin-stage damper, or you can combine that with what's called a pendulum absorber. So these kinds of things can be used to essentially go from the gray line to the black line to the red line. So what we see here is the real differential input vibrations. So the main message here is that you can, through accurate modeling, you can define different torsional isolation systems and essentially minimize the input going into the driveline and minimize boom in the vehicle. So that's how you would address something like that. And another example here, looking at series hybrids. So this is an example of a range extender. So the engine is connected to a generator, but then you're electrically propelling the vehicle through a drive unit, and there is no physical connection between the engine and the wheels. So in this case, you have some latitude in terms of how you can define the engine speed profile when it comes in, etc. So I'll just play one example for you here. You'll notice it's an EV mode initially, and then the engine kicks in. So hopefully you heard that. So it's relatively silent or low noise levels in EV mode, and then the engine kicks in, and the noise levels go up, which is okay. But the main message here is how do you tune the engine speed profile to be consistent with the power demands of the vehicle, but at the same time be acceptable to the customer. So what you saw here, we have a profile like this in green that goes up, and then there's the increase linearly where the engine noise goes up in a linear fashion with the vehicle speed. So some key factors to keep in mind. You want to minimize operation of the engine at low vehicle speeds and not make it as objectionable. You want to avoid constant IC speed operation, although this is feasible technically, but it's not acceptable from NVH perspective, and including some sort of a ramp up. So you have this linear sort of feedback to the customer so that it matches what they expect from a vehicle speed and associated noise. Okay, so with that, I'd like to step into BEV, NVH challenges and solutions. And what you'll see here, to a certain extent, is very similar to what we heard from Dr. Akhilesh Sharma in terms of optimizing all the attributes, right? This is a typical BEV development, and I won't go through all the bubbles here, but you'll see so many things that need to be balanced. So you do need multidisciplinary optimization. You need a systems-level view to make sure that you're not working in isolation on anything, but in concert, optimizing the vehicle. And NVH is a big part of it, but it has to work in concert with all the other things. So with that, also another plot here which is very similar to what we saw earlier today. So if you look at HEVs or IC engine-based NVH issues, it is significantly powertrain driven, right? That we all know that. But as you go towards BEVs, of course, road noise becomes very important. Powertrain noise is still important, but it's got a different flavor to it. Wind noise is important at high speeds, and definitely all the other auxiliaries that cause noise, all that need to be managed. So yeah, so there's work happening in road noise development, wind noise development, EDU development, active sound design, which we will touch upon later, as well as light weighting. So let me maybe give you a very, very brief overview on each of these topics here, and in the later presentations from Dr. Christoph Steffens and Jan and myself later in the day, we'll touch upon a little more of these areas. So this is just an example of a ICE-based vehicle and a BEV, which is in the same vehicle. And this is the same vehicle where we exchanged the engine with an electric drive unit. And as you can see, not surprisingly, there is a 5 to 10 dB drop in noise levels. So that's to be expected. Noise levels are lower for BEVs. But also what you see on the bottom blue line is noise induced from the tire. And this does not include wind noise because it was in a chassis dyno. So the main message here is that you need to be able to balance EDU, induced noise, road-induced noise, and wind-induced noise. And this has to be done carefully to define the DNA of the vehicle. You also need to have a strategy to blend what's called AVAS noise. AVAS stands for Acoustic Vehicle Alert Systems. So in different regions of the world, there is legislation where the vehicle needs to make more noise on the outside at low vehicle speeds through speakers to alert pedestrians and blind pedestrians in particular to make sure that it's safe for them to hear the vehicle coming. So with that, there's these AVAS systems that are being developed, but you also need to integrate that carefully so it does not make the interior noise worse than it already is. And of course, you need to minimize noise from other sources. So I'll step through a few of these and at a high level, and then hopefully give you a flavor. So from an EDU, induced noise perspective, this gray band here is a scatter band of road noise and wind noise. Yeah? So if you start with that, you see that your EDU induced noise needs to be lower than this band in order for it to be masked enough and not be intrusive. And there's different parameters like tonality metrics, etc., that can be used to define these targets. So fundamentally, you need to use advanced NVH tools, be it multi-body system and FEA, and we'll talk about some of these later in the later presentations. And then you get into EDU and NVH testing, and this has to be also done. There's a role for testing also here to make sure that you can refine the EDU and NVH characteristics. And last but not least, mount development and integration into the vehicle through use of advanced transfer path analysis and techniques like that. So if you do all this, then you're able to monitor and control the EDU noise to be where you want it to be. The next area is road-induced noise. So I'm just showing you one plot here. It's x-axis of frequency and tire speed on the y-axis. The third axis is noise levels, of course. So as you can see, the noise characteristic is it does not have a character, but you have all these orders, which can also cause whine from the tire. But if you spread them out, then you get more of a broadband noise, and each order is not as obvious. So how do you manage road noise? First of all, you look at the tire itself, and you have this asymmetric block design to minimize tread-induced noise. And then you can look at inserts within the tire cavity. One example is shown there to minimize what's called tire cavity noise in the BEV. And lastly, you get into vehicle integration, where you have to look at advanced technologies like transfer path analysis, etc., to see what can be done to minimize the noise from different suspension pads. How can you modify it? And after all that, there's also road noise cancellation that happens actively that's coming into play, where you can use the speakers, you use accelerometers at locations at the suspension inputs, and you use that to actively cancel the noise inside the vehicle. So all these things are happening to minimize road noise inside the vehicle. And of course, the next is wind noise. So again, here you have to have initially simulation-based techniques. We show examples of CFD here, and then some level of correlation with test data to make sure that we are focusing on the right areas. So you have to use simulation techniques initially from defining the vehicle architecture to minimize wind noise. But then you get into test-based development later, including testing in an aeroacoustic wind tunnel to define your wind noise characteristics to be reasonable. So in addition to that, there's use of acoustic glass, where you have a laminate with tuned characteristics to minimize the wind noise intrusion through the windshield and the side glasses, and also development of sealing mechanisms, etc., to make sure that you're able to manage the wind noise to be reasonable in the vehicle. So these are all the factors to consider. Then the next topic is looking at HVAC noise as an example, but this falls in the category of all these miscellaneous things like AC compressor, power steering pump, vacuum pump, cooling systems, etc. All of those can cause issues, but I'm picking one example here. So what you see here, this gray band, is the gray band of let's say, scatter band from FEV for idle noise in a conventional IC engine vehicle, which customers are used to. So if you look at that as a backdrop, and you see the HVAC fan-induced noise at levels 0, 1, 3, 5, 9, etc., you'll notice that the fan noise itself is that much higher than what a customer might be expecting from just idling of the vehicle, of an IC engine vehicle. So this puts in perspective, when you don't have the engine idling, what kind of issues might you expect? And so something to keep in mind so you can optimize all these sources separately. And I talked about AVAS, or acoustic vehicle alert systems, and this is just one example here to say you might have something like this when the vehicle is operating at low speeds to satisfy the legislative requirements on the outside of the vehicle, where the pedestrians need to have the vehicle be audible. But in doing so, you want to make sure that the interior noise doesn't look as bad as something like this, where the customers might already be expecting to have a quiet experience and they're hearing these speakers. So you don't want to do that. So you need a structured process to maximize the AVAS-induced noise to the outside, but minimize the noise intrusion to the inside. So we'll spend some time talking about this also in one of the latest sessions today. And lastly, we have a session on acoustic sound design that my colleague Christoph Steffens will present later. But I just wanted to mention that acoustic sound design can also be used to mask this AVAS-induced noise, so such that you have something like this in the vehicle, which defines the DNA of the vehicle, but also masks the AVAS-induced noise inside the vehicle. So with that, I'd like to briefly summarize this. So the global drivetrain trends clearly show that we have both HEV and BEV development happening. Electrified vehicles do present new challenges, but there's also solutions available that we can work on. The solution of HEV vehicles in particular requires a good understanding of the vehicle architecture, the hybrid architecture, because that defines what the noise mechanisms are and where the solution potential might be. Sound levels in BEV, as we saw, tend to be lower, but they have, basically issues that need to be understood with respect to EDU noise, road noise, and wind noise, and all noise from all the other sources. And finally, we talked about active sound design, which has potential to craft the sound of the vehicle to be what you want it to be, to what your customers want it to be, and hopefully that be a pleasing experience. And FEV has tools and methodologies in all these areas, and we're more than happy to engage in discussions with you to see what we might be able to do to support you. So with that, I'd like to stop my presentation and hopefully take some questions if you have some time. Thank you. Not sure how much time we have, but I'm available now if you can, and also later in the breaks.
Uli Pfahl, FEV. Kieran, thank you. Really great, interesting talk. I liked all the examples. One question, when you go to that really lower noise level on a BEV, what new sources you could not hear before in an ICE vehicle become relevant?
Yeah, exactly. That's a very important point because the masking level goes down, and so everything else becomes important. So yeah, there is AC compressor noise, there's power steering pump noise, there is fan noise, and there is HVAC noise, as well as HVAC fan noise. All these things are examples of what might become more important, and certainly will be more obvious to the customer in the absence of the IC engine noise. So it does require an understanding of each source separately, such that it can be customized to what the overall noise signature needs to be in the vehicle. There's a question in the back there.
Hi, Dr. Kiran. Am I audible? Am I audible?
You are.
Okay. So in the last slide that you talked about the active sound design, which you are also offering. Is it something which FEV has developed as a customized solution, or is it something which with the normal, regular softwares which you usually use for testing, you are plugging and doing something like that? I would like to know more about that part.
No, there's a specific process, and FEV has some methodologies in terms of developing the sounds and integrating them into the vehicle. And in fact, we have a presentation on exactly this topic that my colleague, Dr. Christoph Steffels, will present later this afternoon on the topic. Yeah?
Okay, thank you.
You're welcome. Is a question there?
Hello, sir. Sir, I want to ask the question regarding to the IC, BV, electric and hybrid. If you want to reduce the noise, so which one is the best option where we can reduce it?
Between all the different architectures, you mean?
Exactly.
So all of them have unique challenges and unique targets that they need to meet, right?
Yeah.
So arguably the hybrid configurations are the hardest because you have noise sources from the IC engine as well as from the EDU, in addition to road and wind noise, and the transitions between the various hybrid modes. So in terms of what is most challenging, if that's your question, I would say that is the most significant.
Okay. So means then the hybrid option will be the best in that case, according to the present market scenario? Means electric and IC both?
Yes.
Okay.
So the hybrid operation depends on the type of hybrid, but fundamentally you have two sources of power. It's electric as well as IC engine, and the split between them can change depending on the architecture.
Thank you, sir.
You're welcome. Are there any other questions?
Kieran, I have one more question talking about cost. So of course, there's usually one budget for NVH, right? If you really design a new vehicle. So you have your component optimization regarding NVH. Then of course you have your system optimization, you have your integration, and you have calibration. So having more and more advanced tools also available, how do you see the shift? Where is the budget going? Is really more upfront loading and simulation, and how can we optimize to, of course, get a better result at a lower cost?
No, this is a very valid question. Cost is extremely important, especially BEVs. So anything that can be done to minimize the development cost is very significant, of significant importance. So there's a lot of front loading. The simulation-based tools are clearly the way to go, because you can minimize the number of prototype vehicles and also minimize the number of problems to be expected later. So significant simulation work, be it multi-body systems analysis or FEA analysis, CFD analysis, is all extremely critical in order to have a best, let's say, a best starting point from a prototype vehicle so that you can minimize the actual development effort later in testing. That's the trend we are seeing. In fact, we're also hearing from some companies that they're going to be doing testing only to improve the correlation with the simulation. So the testing-based activities are really focused on improving the models such that in the future, you can rely more and more on models and less on testing. So I think that's a clear trend. It's a very valid question.
I just want to add to that. I think the same is true. The more budget will go into the simulation kind of a thing, where you have a very clear kind of things, component level, addressing the kind of NVH noise in the simulation itself. And you need to have that correlation, what you mentioned.
Exactly.
So if you have that part of it, right, and then you can take decisions based on simulation. And you don't need any big surprises from, development aspect. Thank you.
Thank you. Okay, one more question.
Hello, Kiran. Yeah.
Can you use the microphone, please?
Yeah, Om Kumar from Switch Mobility. I was wondering that all these noise levels, I see that primarily it is passenger car that you are considering.
Yes.
So any perspective on commercial vehicle, primarily bus application? And again, this is second question. Now considering Europe and North America, I assume that the environmental noise is at different level compared to Indian market, where environmental noise itself is 5 to 10 dB more than, or maybe more. I can. So how do you see that these things are going to impact design as a user experience? Finally, noise, acceptance of noise is a relative term. How much a person is going to accept as a good noise. So again, I hope you are getting my question. One was commercial vehicle versus passenger car, and another was noise level in European market versus India market.
Yeah, so let me attack the first question first. So commercial vehicles, the fundamental process is not different. Fundamentally, what we're seeing in terms of light duty typically makes it later into commercial vehicles also, from our experience. In fact, we worked on Class 8 semi-trucks as an example. And in fact, one application we're working on as we speak at FEV is a series hybrid architecture with an EV mode. So the main message is very similar. They want the driver experience to be very nice because the drivers spend a long time on the roads driving. In fact, many of them spend 10 hours plus on the road driving. So they want that to be a pleasant experience for them and not have driver fatigue. So to that extent, it is similar. Of course, the target setting process is a little different. You have to do a different level of benchmarking to understand what is reasonable and develop to that, right? When it comes to pass-by, I can give you a US perspective. It's not as significant in terms of meeting pass-by noise. So the levels are there to be met, but it's not necessarily a concern and not too different from what we see with IC engine-based vehicles. So I don't see that being an issue, at least from the North American perspective. Maybe Christoph can provide some perspective on the European market in a later presentation on pass-by noise, but that's at least my thoughts on the North American market. Yeah?
Sorry, I have one more question. Yeah. Oh, sorry. Kiran, what are the unique challenges for the FCEV, means fuel cell electric vehicles based on hydrogen?
Yeah. Good question. So fuel cell electric vehicles are a very small part of the market right now for light duty, but it is becoming very important for medium and heavy duty, right? So you're talking NVH challenges in particular. So I can give you just an anecdotal example. I drove the Toyota Mirai first generation fuel cell vehicle maybe 6-7 years ago, and it had significant issues with respect to compressor noise, injector noise, and even water noise. I mean, just imagine when you have water's emissions, you have fluid sloshing noise, right? All these were obvious, right? In addition to EV, EDU noise, right? And so it was, kind of interesting to get used to. But I drove the second generation Mirai last year, and in fact, we are benchmarking that at FEV. Significant improvement, significant, to the point where all these things are not obvious anymore, right? This shows what we as engineers can do, right, given time and money.
Thank you.
Yeah, please let me know when I'm running out of time here, so I'm...
Yeah.
Okay.
Yeah. Sir, as you have shown the trend that ICE vehicle is going to be there till 2040. And all the OEMs currently working on the hybrid approach for the vehicle build. The vehicle, they are specifically building it for ICE and they're converting into electric. So how the approach of the OE should be in terms of different noise levels like body-borne noise, engine-borne noise or motor-borne noise. What should be taken as a worst-case criteria for defining the vehicle noise level, not in terms of powertrain, but in terms of other sources? Do you have such an approach over in FAV?
Yeah, maybe I'm not sure I completely understand the question, but perhaps we can talk in the break if that's okay. I'm available to talk in the break.
Yeah.
I'm not sure I understand the extent of the question, but I'm happy to discuss this.
Kiran, what is saying, the India market current trend is not to, there are almost 3 years will required to born EV platforms to be get established. As of now, 90% of the vehicles in India market, EVs, are ICE to BEV conversion.
I see.
Okay, so Kishore, hold on till 4 o'clock. I am going to give you the ICE to BEV conversion NVH challenges. Yeah? Okay.
No,
Thank you,
fair-
thank you.
thank you. That's a good answer because Sachin has a presentation on this topic later. Okay, well, thank you very much, and I appreciate your questions. Look forward to talking to you.
Thank you so much, Dr. Kiran, for such an informative session and your valuable thoughts. Now, I would like to invite Dr. Christoph Stephens, Department Manager, Global Chief Engineer, NVH at FEV Group, on stage to present on EV NVH development and target setting. Dr. Christoph Stephens has been actively involved in the NVH industry for more than 26 years and has extensive experience in crafting for electric vehicles. Please welcome him.
Yeah, welcome also from my side. I'm really honored and proud to be here and make a presentation concerning EV NVH development. To be honest, a lot of topics are already tackled. Yeah, so a lot of things which I would like to mention here in that presentation we have already discussed, but I try to give some new sides on it and to bring some new views on it. So what do I have planned? First of all, a short introduction to come into the topic. Then I will specifically talk about development processes, and especially about the NVH development process. And one very important target of such a process is target setting and target cascading, especially when we are talking about these new vehicles. Yeah, for ICE vehicles, we have a lot of experience in the background. So we know the predecessors, we know everything about that, and so it's easy to evolute, yeah, to perform evolution on the vehicles. But EV vehicles, especially when I talk about new vehicle structures, not ICE to BEV, but new vehicle structures, we have no experience. So we have to find ways how to handle it. Well, starting with a short introduction, it's very important for me to mention this here. We've talked about FEV, that we started 1978 in Aachen with 3 engineers. We are now more than 7,000 engineers. But even at those times when we were dealing with diesel injection systems or diesel combustion, NVH was a very, very important topic, and it's still today. So we are within FEV, more than 150 engineers worldwide. We have a lot of test cells. We have a high academic rate in general. And as I mentioned, more than 40 years experience multiplied by all the people who are working there. And coming to Germany, I'm from Germany, from Aachen. From these 150 engineers, approximately half of them are located in Aachen. You've seen all the facilities of North America. Kieran showed that. In principle, you can say you can double that to Germany. I have listed here only the NVH facilities which we have in Germany, so component test benches, similar for e-motor testing, ICE testing, but also EDU testing. We have a vehicle chassis dyno, and in addition, a NVH measurement room, where we can change temperatures from approximately 10 centigrade up to more than 30 centigrade. So this allows us to perform also measurements under climatic conditions. And last but not least, we have a proving ground where we can make high test speeds, where we have rough and bare road areas, and where we can measure pass-by, for sure. Just as a short view on what we have in Germany, so that you get a clue what's worldwide available at FEV in the NVH area. Now coming a little bit more into the topic. We have seen that. So we have currently a lot of megatrends acting We have new mobility concepts, car sharing, for example. We have connected mobility. We have ADAS, so assisted driving. But we have also electrification, which is a real big trend currently. We have seen that. Kieran has shown several graphs where we show how the share of battery electric vehicles will increase in the next years. Independent of the market, this will be a little bit different, but it will grow, and that's the message. And just to give an example how fast it can grow, I brought with me this example here. This is New York City, 1900s. This is Fifth Avenue, and you can see the traffic here. So you see a lot of coaches, mainly. And if you look very, very good and in detail, you can see here, that's the first automobile, 1900. Henry Ford said, if I had asked people what they wanted, they would have answered faster horses. Yeah? And now, 13 years later, only 13 years later, same street, same time, Easter, you see automobiles only. Stop, there is one coach over there. So the picture has changed completely. And what I would like to say is, we have that change right now. We go in the direction of battery electric propulsion. And we as acoustic engineers, we have to recognize that, and we have to start our activities, and we have to increase our activities in that area. That's very important, and that's what we have to do. We have talked about that today several times. Coming from the ICE propulsion to the battery electric propulsion, the noise shares, they will change. And especially the masking noise of this loud combustion engine will vanish, will be away. But anyway, you see, I've shown here for a battery electric vehicle the different noise shares versus engine speed. And what we can see is that, like we had it for the ICEs, even here, the EDUs, or the propulsion system, has more or less the highest noise share, especially at lower speeds. Yeah? This curve here, this green curve, the Powertrain, is on a really low level. Yeah? For ICEs, the level, especially at higher speeds, will be much, much higher. Nevertheless, EDU, from level perspective, is still important, even for the lower vehicle speeds. But anyway, at higher speeds, latest at 50 kph, road and wind noise will dominate. And so we have more or less really take care about these noise shares. And in addition, you see here at the beginning also that AVAS sound. Kieran already mentioned that. Up to 20 or 30 kph in the US, we have that AVAS sound. And even this makes noise. Yeah? Also in the interior, we've learned that, in the exterior. And so also this is something we have to take care. And especially the AVAS noise, if you think about the situation, okay, in India it's a little bit different because you're using the horn very often, but you know in Europe the horn is not used, so you have only the car which is acting. And if every car is now radiating this AVAS noise, I'm looking forward to hear that, but hopefully we can manage it, that this is not disharmonic. Yeah? So I think on a higher level we have to talk about how to design these sounds, how to have a branding on the one side, on the other side they should fit to each other. Nevertheless, that means noise shares have changed, we have seen that, and we have now new players in the game or old players, but with more important, that's road and wind noise. We have the EDU on a lower level, but the electric drive noise unit has less noise level, but because of the whining noises from this component, we have a noise quality issue right now. Yeah, so this is not a noise level issue, but a noise quality for the EDU. Active sound design, I will talk about that later in the afternoon. Anyway, the general requirement for weight reduction, because of the driving range, that's really a burden for NVH. Dr. Akella talked about that. Yeah? Typically, we need weight to improve NVH. But in this case, we have to find ways how to increase the weight not that much, or maybe can save somewhere else some things so that we can balance it. That's really a challenge, and that's what we are working on every day. Well, coming to the NVH vehicle development process. So we have seen the challenges of a battery electric vehicle, and now we have to check what does it mean for the NVH development process. You see here the milestone of a typical NVH of a typical vehicle development process, and below that you see what we are doing in the NVH area. And NVH has to be incorporated in these processes from the beginning. Yeah? That's very important. To get a very good result at the end, we have to start directly at the beginning. And directly at the beginning, we need benchmarking. We need to know, or we need to understand the system of a battery electric vehicle. We need to know where we have to keep an eye on, so what is a must and what is nice to have. Yeah? All of these things we have to find out here. And based on this, we can make a first draft target, which then continues with the NVH target setting process. And NVH target setting process means starting on vehicle level and cascading it down to component level. I will talk about this a little bit later on. And very, very important, Dr. Keller, you've mentioned that. We are NVH guys, and we want to push NVH, NVH first, priority number one. That's what we want. But anyway, there are others. We have to recognize that, and we have to accept that. So we need a balancing of our targets, of all the NVH targets to each other, but also to all the other targets like durability, like crash, and all these things. And after these things, NVH monitoring starts. That means we always have to monitor if we reach the target or exceed the targets. If we exceed the targets, we have to work against that. And then the validation process starts. Very important, CAE, also, this is something we have already talked about. Front loading is really increasing. Everywhere where I am, front loading increases. And we see it on the testing side that a lot of more testing will be done virtually. So in the virtual world, we will develop and we will really test things so that we can reduce the testing activities later on. And even the first designs, the first prototypes are more robust, are much better in terms of acoustics when you spend a lot of time, a lot of effort in the first phases. So which topics we have to tackle when talking about NVH development? We have to think about the structure. So the body structure and the body structure sensitivity is a very important topic where we have to start with directly at the beginning. Airborne noise, we have to talk about. Powertrain noise, road and wind noise, we have talked about that. auxiliary noise, also very important. But also those things like squeak and rattle. Maybe at this point, for me, it's also very important to tell or to say, if we talk about a battery electric vehicle, if we talk about electric motor propulsion, you know, everybody knows ICE is loud, electric motor is quiet. So the expectation of the driver, the expectation of someone who is buying a vehicle is much, much higher in terms of NVH and quality aspects than for an ICE vehicle. And therefore, everything what you hear as a driver, and you hear a lot in a BEV, yeah, that's critical, and that's more critical than in ICE vehicles. And squeak and rattle also come up because masking noise is reduced, yeah. And so even if it's the same vehicle, the same interior, the same trims, with the same squeak and rattle, it's more obvious in battery electric vehicles. Air leakage, customer actuated noise, sound design, we have already discussed that. Homologation, well, if you look ICE versus BEV, in Europe we see that there is an overlap in the meantime. Yeah? So we have really gasoline-driven vehicles which are quieter for homologation, yeah? Only for this test setup, quieter than some of the BEVs. Yeah? That shows a little bit the difference is not that big. And the reason for that is road noise, yeah? Road tire noise, which is really critical for pass-by, especially under accelerated condition. And in Europe, we are currently talking about to reduce again the limits. And we are right now at 68 dB for the pass-by, and we talk about 66 dB for the pass-by. So additional 2 dB difference. And with 66 dB, for a typical N1 vehicle, we are in the area of the road tire noise. Yeah? That shows the challenge which we also have here. Anyway, all these things have to be tackled and have to worked on during the development. I will now have a short look on some of these things. One very important topic is for us body structure sensitivity, and the torsional stiffness is one key factor which we can use to judge the body structure sensitivity. And you see here a short benchmark. There are 4 competitors, and vertically you see the torsional stiffness, and you see that we have there a range from 20 kilonewton meter per rate to 35. Anyway, if we talk about BEV, we have to prepare the structure for the higher mass of the propulsion. Yeah, so we bring in higher mass, especially from the battery, and so we have to check and we have to try to improve the stiffness of the structure to come up with the same eigenfrequencies at the end. And very interesting here is when we look to the contribution of the battery integration, you see that depending on the competitors, the battery brings in 25 to 35% additional torsional stiffness. And that shows us that the battery integration is a very important thing in terms of structure sensitivity. And just to give an example here, what we can do and what are the effects, you see here that coming from a baseline, in a first step, we have optimized the battery frame, and we've gained 2% structural stiffness. In addition, we have improved the rear attachment of the battery, and we have gained, again, 4%. You see, there is potential. You see, we have to work, or we have to be very careful here, especially for battery electric vehicles. Road noise, we have tackled that point, and we will tackle it later on very intensively. But also here, very important simulation, CAE activities directly from the beginning to analyze the transfer path from the road tire contact to the interior or from all these structural vibrations into the interior. So that's very important, but also benchmarking will help us here to understand more what's going on there. One very central part for all our activities is a TPA-based tool, which we call Chassis Wins. This is a tool which allows us to really analyze in detail the transfer path from the road into the interior, and that's what we are often use to analyze the vehicles and to optimize the vehicles to get information about the critical paths and to work out countermeasures. But we will see later on more about this. Just to highlight this here a little bit, when we talk about road noise, it's clear the road noise itself is independent from the propulsion. Yeah, so if we talk about ICE or if we talk about EDU, that doesn't matter. But road noise depends on the vehicle architecture. So if we change the vehicle architecture, we have to be very careful how to do it so that we do not deteriorate the road noise. That means when we look at BEVs where we have a higher vehicle weight and we have more powerful propulsion, that requires that we need new vehicle structure designs and that we have to adjust the chassis, not only because of NVH, but also because of vehicle dynamics. And also here, a short view in our benchmark data. I have chosen here 3 vehicles. The black one and the green one are BEV vehicles, and the red one is an ICE vehicle. All of a C segment. And what we can see here is the road noise. And what we see in addition is that, especially at higher frequencies, the BEV vehicles are much better in terms of road noise than that ICE vehicles. Despite this one point here, but this is really based on this new vehicle architecture. So we see road noise has been improved with these new vehicle architectures, and we have checked the vehicles, what is the reason for that. And what we found when we had looked on the acceleration at the wheel carrier at the front and rear axle, we saw that here we have a stiffer, especially here at the green area, a double wishbone front axle, wheel carrier. So that was the reason why the acceleration here is so low in comparison to the other two, so that we can see, here we have a better vehicle structure, but we have also a more complex and a more stiff chassis geometries. Aeroacoustics we have talked about. I will not go through this, but we see that the new vehicles, they have certain design aspects which will help us from the NVH point of view, which help to reduce the resistance on the one side, but which also help us for aeroacoustical topics. So we have that teardrop approach, which we often see. We have that closed shutter at the front, and all the other things you can see here. And in addition, meanwhile, we exchange the side mirror with a monitor, and this will reduce these eddies which we have behind the mirror a lot, and which will help us to reduce the wind noise significantly. Anyway, also here, we have seen that in the presentation before from Kieran, we have to be very carefully, directly from the beginning. Therefore, CAE, CFD calculations can help us here to optimize all these critical areas at the side mirror, at the A-pillar, at the wiper area. However, this will help us to optimize also the aeroacoustic points. Also, behind these level things, yeah, a low level, high level, loud road noise, loud wind noise, we also have to take care about sound quality. I've mentioned that at the beginning. And there we have different disturbing noises in the interior for a BEV vehicle. It's the EDU-related whining noises, which we have from the electromagnetic excitation, from the gear meshing, but also from the inverter. And all of these things we can optimize really efficient with simulation. So we can optimize the tooth forces, that means the teeth and tooth geometries, macro and micro geometries. We can optimize the teeth of the stator, for example, to reduce the dynamic electromagnetic forces and so on. So this is a basic thing we have to do. But also, I've mentioned squeak and rattle, yeah, which becomes more important. Also here, in the meantime, we have good simulation tools to tackle with that problem and to forecast if it will rattle, squeaking or not. Yeah? And also this is very important to use and to work on it. The third point, which I would like to mention here, and there are a lot of more, are the mechatronic systems. Also, this is something we have already talked about. Due to the demasking, we have all these mechatronic systems are more or less audible. Pumps, AC compressor, power steering pump, the complete HVAC system. Yeah, you see, that's the HVAC here. So I think afterwards we have to optimize all these things here because that's the same topic here. Just one example to make it clear what I'm talking about. You can see here some curves of battery electric vehicles, and that's the AC compressor noise only, which we have measured. And the gray area, that's the idle noise of a combustion engine. And we see typically this compressor noise is masked by this idle noise of the combustion engine, but if this now is removed, and we know that the electric motor is not that loud, no, it's clear. These things are demasked, and they will be audible in the interior of a battery electric vehicles. Just to show this here, what you see here are airborne noise transfer functions from the AC compressor into the interior. And one scatter band for the battery electric vehicle in yellow, and one for the ICE-driven vehicles in gray. And what we can see here is that the transfer function of the BEV are much, much more critical. And why that? We've already talked about that. Mass weight increase, so we have to save mass somewhere else. And here, it was really saved on the wrong area from the acoustical point of view, in the area of the firewall. Yeah? And so the compressor noise is now more able to come into the interior. So this is something where we have to find solutions that the sound pack is brought into the right area, into the right position. And somewhere else where we do not need it maybe that much, we can reduce it. Yeah. Nowadays, you know, the AC compressor for BEV vehicles, they are not mounted anymore on the propulsion. They are now mounted on the vehicle. Often, also there we have to isolate. We have to find a double isolation to avoid that all these things are coming into the interior. Just an overview, we are working on those projects day by day in North America, in Europe, in India. And yeah, that's the message here. Just a short view, because time is running, on the target setting process. Also, we are working with the V process, meaning that we have the customer requirement, the voice of customer. These targets we mirror to the vehicle level and then cascade it down to the component level. After design and implementation, we have the validation. And this has to be done for the NVH as well. So we have to define the target, cascade them down, and validate them. And very important, not only on the testing side, but also on the virtual side. We have talked about that before. So how can we do that? How can we define all these parameters which we need? Forces, displacements, sound pressure level, vibration level. How can we define this? And that's really a question. What's the way to go for this question? I've talked about that. We can use predecessors if we have one. Yeah? For ICE, it was clear, and we could learn from the predecessor and evolutionally develop the new vehicle. That's not valid anymore, so we need some other approaches. One of the approach we already have in process is benchmarking, meaning that we have to analyze current on the market available battery electric vehicle. AVV has a benchmarking program where we investigate new propulsion system vehicle. In that benchmarking program, we are also able to sell you the data, to provide you the data for different aspects, not only for NVH, but also from design perspective, consumption perspective, and all these things. At the end, we are able to end up with scatter bands on vehicle as well as on component level, which are based on all these activities. And these scatter bands on every level can help us to find targets and to position the targets for our product which we would like to develop. In this context, just a short comment. Sometimes it's difficult to, we have the interior noise, for example, and we want to analyze it. We want to know more how is the, what are the shares and what are the percentage of the shares of the interior noise. What is coming from the EDU, what is coming from road noise, what is coming from wind noise, what is coming from the AC compressor, whatever. So this is typically a topic we have to tackle with. And to do this, we have developed a new tool which we have called AVINA, Automated Analysis of Vehicle Interior Noise. And for this, we have introduced AI technologies. So machine learning, neural network, especially convolutional neural networks, that is what we use here to set up a tool which allows us to extract all the different noise shares, noise components from the interior noise. So at the end, when you use that tool, you get a noise share, you get a Campbell diagram of the EDU induced noise, you get a Campbell of the road induced noise, and so on. So you can really directly judge what is coming from which noise source. You can do it very simple with a diagram like this, but you get the information, what is the critical component for your interior noise. And in addition, there's also included a rating of the pleasantness. This is also valid in addition. Yeah, so this is something which we currently introducing in our analyses, which allows us to be quick in analyzing the interior noise of a battery electric vehicle. Just a short comment. All the benchmarking, all the processes which we have, they are good and they are working. But experience is also necessary. So we need people, we need well-skilled people who can make these analyses, who can set the targets. We need benchmarking data, which is the base for all these judgments. And we need methodologies and procedures where we bring in all these knowledges and which help us to come to targets. One additional approach is the vehicle, to build up a physical vehicle road. We can come down to the noise source, and we can define targets for the noise source. And this is done in the following, just very, very quickly. This is concerning whining, EDU whining, reducer whining. And what we can do to define the targets for whining noises is that we use the masking noise of wind, roll, and maybe fan noise. If we know that masking noise, then we can define the permissible tonality of this component, EDU, electric magnetic noise, or gear meshing noise. And with the knowledge of the transfer functions, we can define the airborne noise or structure-borne noise targets then on component level. And for this, we are using our tonality value, which is a value which evaluates the difference between the tonal component and the corresponding third octave, and also the difference between the overall noise and the tonal component. And this gives a tonality rating at the end from 1 to 10. And what we do here is that we invert that we say, okay, target is a tonality value of 8, and with this, we can define, let's say, these numbers here. So the difference between the tonal component of the corresponding third octave or to the overall level. And with this knowledge, we can define the allowable level for the interior noise for different speeds, like shown here, so that we have the targets on vehicle level. With the knowledge of the transfer function, we can go into the component and also define here the targets for on component level for different speeds. Yeah, because the order is going through different frequency ranges at different speeds. You see here the targets in yellow, so that at the end we have these targets, and we can compare that, for example, here with two different transmissions in this way, in this case, for the airborne noise, but also for the structure-borne noise. And you see that the red transmission is always above the target, the green one mostly below the target, so fits the target. And if we compare this with the vehicle interior noise at the end, you see that it corresponds. So the red one has exceeded the target, so this transmission whining noise is audible, and the green one is below the rating 8 or higher than the rating 8 in this case. And that's a way how to define targets in addition, besides the benchmarking using such a physical model. With this, I come to an end, and I will not go through all the things I've talked about. But anyway, what we would like to show is that we know how to develop battery electric vehicles, where to take care. We have solutions, we have methodologies. Maybe there's improvement. I think so, to be honest. But anyway, I think we have a good toolbox. We have good people to develop with you together the new energy vehicles. Thank you for your attention. Yeah, so I'm open for questions.
Yeah. So floor is open for the questions. Anyone?
Yeah, my name is Kishore. I'm from Tata Motors. My question is regarding nowadays the electric vehicles. If you see the mounts, the EDU mounts are coming onto the subframe side. So if you compare IC versus electric vehicle, apart from these mounts, the AC compressor is also mounted on the subframe. So my question is specifically to the target. Like what should be the target for the mounts which are coming onto the subframe? And as Dr. Akala sir has told, we have drove our benchmark vehicles and we found some of the booming issues. So my first question is what should be the targets, how to set the targets for an electric vehicle, specifically for A mount and or B mount, which is coming onto the subframe. And my second question is, can we use active noise cancellation for the booming issues in an electric vehicle? Yeah, thank you.
Yeah, maybe starting with the last question. Yeah, for sure, active noise cancellation. I didn't mention that in my presentation, but that's an upcoming technology which we can use to cancel specific noise issues, especially concerning road noise. There are systems now on the market. There are systems in development which reduces the road noise, but which cannot remove the road noise completely. The problem of these systems is that they are working only in a certain frequency range, so up to 400, 500 hertz, and that they are very complex, so very, very expensive. But anyway, I think in future, this will be a future technology, and we will see those systems more and more in the market, maybe not next year, but this will come. So this is definitely a technology which we have to keep in mind and where we have to check our environment, how the things are going on. Target setting for the mounting system. I showed that transfer path analysis. And one part of the structural path is the mount. So it's not only one path, but it's different segments. Yeah? So you have the vibration of the EDU, then you have the mount, then you have the transfer in the body, and then you have the radiation from the dashboards, windows, or whatever, and then you have the receiver. And with the TPA, which I've shown, you can describe this path, and especially you can describe the behavior of the powertrain mount. And so this you can use to define the targets, how these mounts have to be done. That's the one way, but I've talked a lot about front loading. I think there are a lot of CAE tools now on the market and available, which you also can use to lay out and to target the stiffnesses, the dynamic stiffnesses, and so on. Yeah, so I think both is possible. And benchmark as well gives us a good hint, gives us a good starting point, yeah, for sure.
Yeah, Christoph, I just want to add one question to. See, this ANC, you just talked about the ANC, active noise cancellation, right? You know what exactly it calls for a cost per vehicle? Do you have any idea? Anybody? In Indian market context only, I'm just talking, it's actually 40,000 rupees per vehicle. And we worked out all the details, and then, you know, whether it is worth in introducing in India as an active noise cancellation. So that's maybe at a premier kind of vehicles we can do that. But at this point of time, ANC is, you know, costing 40,000 per vehicle is really, really, it's a bomb cost. That's another thing. Anyway, I just wanted to add this. Sorry, Christoph.
No, you're right. That's what I'm talking about. They're very complex. They're very expensive. So that's a current problem. And as I mentioned before, the frequency range is not sufficient to do what they have to do. Yeah. But anyway, these things will develop. Yeah, there was another question at the back.
So we talked about defining vehicle level targets, but NVH is system level phenomena. When we plan to transfer those targets for the components, how we do that? TPA is one, but if I look at just motor, right, it would behave differently when I put it on the vehicle versus I test on the test cell or maybe just a setup. How do I transfer that dynamics also while defining the targets in terms of how this is going to behave individually and as part of the bigger system?
So you are talking about, let's say, free field condition in a component test bench and reflections in the engine compartment. Yeah. That's a good point, a really good point. Well, that's really difficult. And to be honest, there are technologies how you can do that. You can, let's say, simulate reflections. You can use free field conditions. But in such a process, we need also approaches which are robust, which are fast. And for this, we have seen that we can more or less neglect these things. We have to accept a certain inaccuracy, yeah, but we go on. We get some values. Yeah. Also, I've talked about the structural stiffness. Also there, torsional stiffness doesn't describe the structural sensitivity, but it's a robust and easy to use value, yeah, which we can use to set targets. And if I look into the German OEMs, yeah, they all use this value. BMW still use that value. Yeah? And the same for those questions. Yeah, you are totally right. There is a difference. Yeah? But and we can consider that in our process, but it makes it complex, yeah, and it makes it slow. And therefore, what I see in the automotive industry is that those things are neglected. But for sure, you have to keep in mind, yeah, that there is an inaccuracy. That's something which is important.
So, doctor, to elaborate more on his question, see what happens, earlier we used to put up on the rigid mountings for all these powertrains applications. But eventually when subframe got introduced, so especially for e-motors, it's always a subframe. So we exactly put up the same subframe. So all the isolations, all the dynamic characteristics of the subframe, like vibration transfer function, acoustic transfer function, point mobility and dynamic stiffness. These are the four. We have to look at all four aspects of the subframe, plus isolation aspect of it, and then that structure is sitting on the rigid mounting of the powertrain test cell. So some extent, almost, or you can say structure-borne noise point of view, this is giving the very accurate result what you are getting into the vehicle and what is you are measuring on it. Yes, but how the vibroacoustic behavior into the engine compartment or motor compartment, that will vary some extent. But when we test on the vehicle level, so typically on test bench level, so we look only in isolation that source. That may not be directly transferred into the vehicle level. Yeah?
Totally right.
Doctor, you have explained the double filtration concept. Maybe could you throw some light on the double filtration in terms of EV?
Sorry, can you repeat it? It's a little bit hard to understand for me.
Double filtration, the mount filtration, isolation. Normally in IC we use the single isolation, but in EV you have mentioned the double filtration.
For the EDU?
Yeah, EDU.
Yeah. We will talk about this this afternoon again, but just a short answer. With that double isolation, you can improve the isolation area, yeah, especially at higher frequencies, and that's what we need. You know, the EDU transports a lot of more high-frequent noises and excitations than we had on the ICE. On the ICE, the highest excitations were for the engine orders. That frequency range was limited, but with the higher excitation orders of the electromagnetic excitation and the gear excitation, we need isolation also in higher areas. And with this, this two-step approach, or two-stage approach, we can increase, especially at the higher frequencies, the isolation efficiency.
Thank you, Doctor. Maybe the frequency range would be somewhere between high frequency, it's 10,000 or?
We will see a thing, but it goes really up to some kilohertz, 2-3 kilohertz.
Okay.
Yeah.
Thank you.
Hello, Doctor. My name is Vikas, and I'm representing Sujan Quantitech, a engine mounting and bushing supplier. So, with the ICE, the challenges for the mounts were very high. But at the moment, there is no clear-cut indication where does the trend is going, whether the complexity of mounting system is increasing or it is going to be a highly simplified mount with a simple solid rubber. So could you please throw some light, where is the global trend is going in terms of complexity of mounts when it comes to ICEs?
To ICEs?
EVs.
Okay. Yeah, I think it depends a little bit on if we talk about trucks or if we talk about light commercial vehicles, passenger cars. But let's stay with the passenger cars. What I see is that more or less all future BEV architectures that they are using frames where the EDU is located in, and with this design you have the two-stage approach, and this is what I see in future. The question is if there is a need to stay without a frame, even there we have possibilities to introduce a two-stage decoupling or isolation. You know, there are brackets available which have a kind of isolation included, a rubber part. So there are, or also rubber in rubber, we have some possibilities. So there are technologies which go in the direction of two-stage isolation, and this is a clear indicator that the development will go in that direction. That's my view, and if I see the developments which are currently ongoing, it's always more or less always a two-stage approach.
So I hope your question has been answered. Thank you so much, Dr. Christophe, for your wonderful presentation and your valuable thoughts. So now, what an astonishing day, isn't it? I request all the guests to move towards the dining area where the lunch arrangements have been made. Let's meet again at 2 p.m. Thank you.
Imagine you're sitting in a car driving on a street and you follow a big van, for example, and you see nothing but the back of the van, and you want to overtake because the van is going slow. So the see-through system helps you to judge the situation. You get the video stream from the car in front of you, and then you can see the situation in front of the big car and decide if it's safe or not to overtake.
This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution.
our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people. journey to digitalize mobility and connect people. Join our journey to digitalize mobility and connect people.
This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution.
Imagine you're sitting in a car driving on a street and you follow a big van, for example, and you see nothing but the back of the van, and you want to overtake because the van is going slow. So the see-through system helps you to judge the situation. You get the video stream from the car in front of you, and then you can see the situation in front of the big car and decide if it's safe or not to overtake.
This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution. This journey of evolution is ours to lead. By driving technology to a cleaner, better future. An ambition everyone can see, touch, hear, feel. We will always keep evolving to help the world evolve. Feel evolution.
Becomes power only when we put it into some use. So let's have a short quiz. Let's honor our knowledge by answering some simple questions. And if your answer is correct, you will receive a nice gift. So brace yourselves. So our first question is, where is the headquarters of FEV Group located? Yes, sir, please. Okay. Yes, right answer. Can you please? Which city? Anyone?
Don't Google it.
Yes, sir, please. Yes, correct answer. So our next question is, when was FAV established and by whom? I repeat, when was FAV established and by whom?
By whom and
No. I repeat question, when was FAV established and by whom? Yes, and by whom?
Let's check.
No. Professor? No. Sir, can you please repeat your answer? Yes. Yes, right answer. So, third question. Our third question is, the faintest detectable noise by a healthy human ear is of, options are 0 dB, 10 dB, 1 dB.
Balavardhan Reddy. 0 dB.
Yes. Right answer?
Gentlemen, please cheers for them. They are answering correct. At least they are getting something out of it.
Moving on to our next question. What does ISO 354 specify? I repeat, what does ISO 354 specify?
Interview question हो रहा है, I guess. Tough questions. Anybody? Your name?
My name is Sohin Doshi. It represents, I think, sound absorption in reverberation room.
Yes, right answer.
Round of applause for them. Shivam. Next question.
So our last question is, which standard test method is used for sound absorption and sound absorption coefficients by the reverberation room method?
Is question clear? Okay, 1 second.
No.
Yeah, my name is Kishore. Reverberation chamber test, I think. Kuhn's tube is for sound material, and this reverberation is generally used for firewall and all these things.
Okay. So option is yes.
You want specific name for the test?
Yes.
No, I'm not sure.
You know, we are technically sound, so we ask tough questions. So that you can trust us that FEV is a technical partner. Anybody else? Guys, now you see कि FEV कितनी tough है technically. So कल तक 10-15 RFQ आ जाएंगे शायद customers can. Anybody else to answer? Question.
Which standard test method is used for sound absorption and sound absorption coefficients by the reverberation room method?
Can you give options? No options? Transmission loss?
No.
Correct? No.
Should I ask another question?
Can we pass? Yeah, you can ask.
Okay. What is white noise? What is white noise?
Yeah, so my name is Amar. White noise is nothing but signal at all the frequencies.
Thank you all for your active participation. Now let's move towards our next session of presentations. Thank you.
Hello. Good afternoon, everyone. Now, we are delighted to have an expert in the field of sound crafting for electric vehicles. I would like to invite Dr. Christoph Stephens on the stage. He will be presenting on sound crafting in electrical vehicles, exterior and interior noise. We welcome you, sir.
Thank you. One, two, 1, 2. Okay, that sounds better. Sorry. Yeah, welcome back from lunch. I hope it was good for all of you. And I will try to give some noise samples right now so that we do not fall asleep and that we keep awake after such a good lunch. Can you switch to the presentation? However, in the meantime, just another question for you. How do we experience products? How do we do that? I think we experience products by tasting, by smelling, by watching, but we also experience products by hearing. And this is what I would like to talk about today. How can define products from an audible perspective. And for this, I've prepared a presentation which deals about sound crafting, sound design, especially for battery electric vehicles. You know, battery electric vehicles, we have talked this morning about that fact more than one time. They are silent, they are smooth, especially road and wind noise are broadband. And so at the end, we have there a noise character which is very emotionless. Yeah, there is no emotion inside, there is nothing which catches us inside. And the question is, how can we change that? And in which way? Yeah. Wait a little bit. It's a big file. It's a big one. No, we got it. Sorry about the delay. Anyway, let's continue. So I would like to talk about how we can experience vehicles in a way that we recognize these vehicles, that we feel which vehicles there are, and that the sound impression gives us a kind of DNA to the vehicle. And for this, we need sound design. And sound crafting or sound design is nothing new. Since 2 or 3 decades, we perform sound design, you know, with passive measures on the exhaust system in the ICE world. We have some active systems included with flaps which we can close and open. So I think in the last 2-3 decades we have done sound design and we refined it step by step. But now the question is, how can we do sound design? And I have two proposals for the beginning. So how to do sound design? Maybe that's a pragmatic approach. Just put a loudspeaker on the roof and play the sound. Yeah? So one approach. The other approach is a more playful approach. So do it in that way. No, I'm kidding a little bit. This is only to start with. In general, when we talk about sound design, so we have to ask, what is sound design? And sound design is, if you look to Wikipedia, it's the art and the practice of creating sound tracks for a variety of needs. But what is very important is that between the sound, so the rational and the emotional parts of the brain, they are directly linked. And they can trigger vivid recollections of the past experiences. That means we hear something and we have a context for this hearing, and all of this will influence how we hear the sound and how we combine rational things with emotional things. Just for the beginning, if we talk about sound design, we can ask, where do we have to do sound design? Interior, exterior, both is possible. How? We can do it actively, passively. And what? We can use sound design, but we can also use noise cancellation. We have talked about that today several times. Anyway, I will not talk today about passive systems and also not about noise cancellation. We will talk about active sound design in the interior and in the exterior. So if we talk about sound design and doing it in an active way, we can do that in principle for all kinds of propulsion systems. We can do it for the ICE, we can do it for the electric vehicle, or for the hybrid, which is a kind of combination, using ICE and EV as a propulsion system. Starting with the ICE, which technologies do we have? We have engine sound enhancement, which we can do, active sound design, or even engine order cancellation. So that are the points which we can use to make an ICE more powerful, to create a sound which is maybe smooth, fits to the vehicle itself. For the electric vehicle, where we have more or less no real sound, nothing which is emotional, we use typically ASD, and we use that acoustic vehicle alerting system for the exterior. So both for the...
We will always keep evolving to help the world evolve. Feel evolution.